Recently, we have known COVID-19 as one of the biggest enemies of mankind. Researchers, scholars, professionals across a range of disciplines like medicine, health, data science, computer science, artificial intelligence are trying to help. My name is Darshan Desai, and I'd like to introduce you to a data science project that can make social impact. This project is about building a risk classification model to predict COVID-19 infections. As of today, that is June 20th, 2020, there is no vaccine or there is no proven medicine for COVID-19. But at the same time, we can no longer afford to be in complete isolation or complete lockdown. And governments across the world are cautiously opening up. So at this point, it is up to individual decision to participate in activities like go to walk or go to work or travel or go to grocery shopping. So in this situation, knowing our own personalized risk of getting infected can be very helpful. Nexoid is a company from UK and they have created a COVID-19 survival calculator. This calculator aims to estimate your risk of infection and your mortality from COVID-19. And their team consists of the professionals from technology field, not from the medical field. With this project, they have created a data set that has about 800,000 records, and more people from diverse backgrounds analyzing and working with this or similar data set, the more likely we are to discover something that will save lives. Using this large data set, we have built a very basic decision tree model, and now Om Desai, a student from Academy of Information Technology, will provide more technical details into how we built and evaluated this model.
Hi, I'm Om Desai, and I'm going to explain to you the technical details of how we built our predictive machine learning model using a software called RapidMiner. This is the RapidMiner screen, and as you can see, RapidMiner is a software that lets you create different processes. And in each process, you can import data, prepare the data, and then use that data to create and test different models. So the first thing we're doing here is we're using read CSV. This is because we downloaded our data from an Excel file with about 780,000 examples, and we want to get this in the process. So we converted the Excel file to a CSV file, and then we're using read CSV to make it so it's able to be used by the process. The next thing we did was to select attributes. So as you can see here, we choose which attributes we want to use in our data and which attributes we don't want to use. So as you can see, I removed attributes that had a lot of missing data, like not every example had data for those attributes available, or attributes that were just completely irrelevant. We also removed attributes that were too likely correlated with the target attribute. For example, there's an attribute called risk infection. If you have a high risk of infection, then of course you're probably infected. So that doesn't really tell us anything, so we removed it. The next thing we did was numerical to binomial. And so this was just to make it easier for us, because in the data we got, whether you had COVID or not was represented by a 0 for false and a 1 for true. We just changed that to true and false to make the data easier to work with. After that, we used filter examples to basically remove any examples that had a bunch of missing attributes with no data in them. So this would make it easier to work with, since all the examples we use in the final data would have all the attributes filled in. After that, we set the rule, and what we did by doing this is basically make it so the model knows that what the goal is to test for whether someone is COVID-19 positive or not. That's why we set the role of COVID-19 positive to the label. Finally, we used this validation, which basically creates a decision tree model and also evaluates the performance of said model. So you can see that there are two outputs. We're using model and performance, and we're hooking up both to results. So we get both the model and the performance of the model as a result. So once we're finished with the process, the next thing is to run the process. And so we've already ran this process, so we can now look at the results. So looking at the results, you can first see that this is our decision tree. Now, the good thing about making a decision tree is that you can The things at the top are more important. So whenever it splits, it shows that it's a major factor in determining whether you will get COVID-19 or not. And this makes the decision tree very easy to understand, and it's easy to figure out whether the decision tree makes sense or not. Now, let's look at the performance vector. So, you can see that basically this is what the validation of the model returns, and it's an analysis of how the model performed. So it shows that there is high accuracy, and it also shows the class precision and the class recall. However, the accuracy might be a bit misleading, because although the precision and recall for one of the classes is good, the precision for the second class is not very good, and this is because the data is very imbalanced. There are a lot more cases of people who don't have COVID than of people who do have COVID. This means that there still needs to be more work in improving this model. As of now, we have built a two-class model, but in the future, we can improve it by building a multi-class model, as well as creating a personalized risk score for people so that they can easily see where they stand in terms of risk for COVID. Thank you.
Our vision here is to develop a holistic population risk monitoring and measurement system that can predict and prevent human sufferings. Thank you for watching our presentation.